Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to continue on in the series that I started a couple videos back of threading on an import lathe. In the first video in this series we went through an extensive or detailed overview of the change gears, how to change them for the desired threads per inch, and in that video we talked about the Imperial thread, but it's the same routine for the Imperial and the metric. In the second video we turned some external threads on this piece of 5/8 material. We turned some 5/8 11 threads per inch threads. And in that video I said in the following video, which is this one, we would turn a nut or thread a nut to fit this 5/8 11. Run into a little bit of issue with that. Let's turn to the workbench right quick and I'll tell you and show you why we had to change the plans for today's video just a little bit. Before we turn to the workbench, let's look at a couple of values over here on the Starrett inch, metric, tap drill sizes and decimal equivalents. If we look at our 5/8 11, it says the tap drill size for that is 17/32 or 0.531. For a 5/8 18, it's 578, 47 thousandths difference. Remember that when we turn to the workbench. Alright, this is the piece of material I was going to use to make the nut for this 5/8 11. I drilled it out 17/32, which again was the 531. And then I started to set this up on the lathe and realized something. The boring tool or the inside threading tool that I have that will fit in here, it will fit in that hole, the point size on it, on these inserts, is way too small. The depth of thread for a for 11 TPI is 59 thousandths. This is the largest or the finest thread, I'm sorry, the coarsest thread this will cut is a 18, which is 36 thousandths. So it's coming up 18 thousandths, no, I'm sorry, 59. It's coming up 23 thousandths short of being deep enough to cut that thread. Hopefully I can show you a little more detail here. This is the internal threading tool I had that would fit in there. Note the size of that point and the depth of these threads. This would only cut about half the depth necessary. I've got an internal threading tool that has a straight point or has a point on it that would make that cut fine. However, it won't fit in the hole. That was the problem I ran into when I was getting set up. I had a piece similar to this that I was going to make a trial run on. Now if you look at that, you'd say, well, all you got to do is round off a couple of these corners right here on the grinder and it'll go in. But to get this tool, to get the point on this tool at the center line of this piece of material would have required that I grind off nearly half of this tool, and that just would not have the rigidity necessary to cut an internal thread. So having said all that, it's not all lost. What I did was take this piece, go back to the lathe, we turned this 11 thread per inch on this end. I turned to 5/8 18, which is a nominal size, 5/8 18. Remember I showed you over on the Starrett chart that the difference between the bore size for a 5/8 18 and a 5/8 11 was 47 thousandths. And that made all the difference in the world. Now, one other thing that I realized as I was setting up, and you'll see this when we get over to the lathe. To set up for internal threading means that the compound has to be turned at a different angle. It's still 30 degrees, but it's 30 degrees on the other side of zero when we're cutting internal threads. And this up in the chuck, there was just too much to try to watch clearance-wise. And I'll show you that again when we get to the lathe and try to film. I have turned many internal threads on something no thicker than this, but I did it with all my concentration on the carriage and how close it was getting to the chuck. So what I decided to do, I got a longer piece of like 1-inch material here, and I bored that for the 5/8 18 5/78. I bored it about 1.5 inches deep in here, and then I doubt you can see it in there, but I used an internal grooving tool and cut a thread relief similar to what we did on the external threads. So we're going to be threading this with this tool, and it's going to be stepped out from the chuck enough so that I've got a split second to react if my mind is on the camera and something's getting too close. Let's go to the lathe now and get set up for doing internal threadings. Alright, if you recall from the last video on the external threading, I showed you a quick way of getting this set up without having to use your protractor under the bottom of the compound. As a matter of fact, some of you, for internal threading, your protractor on your lathe will not be marked off in degrees far enough to get the compound turned over to this side. That was the case in mine, but again, whatever way you determine is best for you to set your angles up, do that. But for me, this is the simplest way. I set the protractor up, this time 29.5 degrees on the other side of zero. Now I'm just going to, you can see what I'm doing right here. I've got this edge of the protractor up against the compound, and I turn the quick change tool post. So what that's done is set the quick change tool post at 29.5 degrees relative to the compound. Now we're going to move the compound, but first I'm going to put the piece of work material in, which this again is a piece that's going to stick out a little bit. And now we'll loosen the compound. Now notice when we were doing external threads, we were at this side, this direction. For internal threads, we're going to come 29.5 degrees to the other side, on the other side of zero. Now I'm simply going to back this out enough, and now we have the flat edge of the quick change tool post square with our piece of work material. And if your protractor on your lathe is graduated far enough around and you can see under there, you would see you're on 29.5 degrees or maybe 59.5 degrees, dependent on how your protractor is registered. The issue I was running into with trying to use something thin like this, and again, I've cut internal threads on pieces held close into the chuck like this, but the problem is that gets mighty close up here. And honestly, I did not want the distraction of doing a recording to take away from the concentration on the threading and take a chance of running into crashing the cross slide into the chuck. So what I decided to do was go with a 5/8 18, a finer thread, and do it in a piece reaching out here so we can concentrate on the thread, and I got plenty of time to stop everything before it gets into the chuck. I want to take just a moment again and do a little bit of explanation. If you've not seen the previous two videos, I highly encourage you to go back and look at them. In the last video, we were looking at the tool like this, in this orientation. We talked about why you go at 29.5 degrees and being sure not to go over 30. If you go over 30, your tool's turned around and you'll be cutting with the heel back here before the point. Exactly 30 degrees you'd be cutting with the entire edge, which we will be doing, but we want to back off just a little bit and start our cut with the point. Now, with the compound turned in this direction for the external threading, what we're doing is moving this tool up 30 degrees as we cut into it. Doing internal threading, we've swung the compound around to 30 degrees or 29.5 degrees on the other side of 0. And now our tool is going to be coming in like such. So we'll be pulling, here we were turning the compound away from us. Here we'll be pulling the compound towards us. So everything on the dial, of course, will be backwards. As you recall, I told you in my little red book here that I had a checklist of things to go over for threading. First one was the proper change gears installed, which I've already got those in. I'll be honest with you, I've made a test run. On the other end of this workpiece right here, I've already cut threads just to be sure I had all the procedures down. But we've got the proper change gears in. We've got the speed selected down here. We have the lead screw engaged versus the feed screw on this one. We have the compound set at the correct angle right here. We have our quick change tool post square to the workpiece. Now we want to get our cross slide handle in position, our compound touched off and zeroed. I'll zero out the DRO axis as well. We won't be using an indicator in this case. This is a snug fit to begin with here. All right, so we've got our tool in now, and we position it such that it'll go in. Now I'm going to bring my compound handle. I want to screw on the compound handle. The handle on the compound, I want it at the bottom. And I'm going to set that to 0. Remember, we'll be feeding in, so any backlash I want to take out for the feed in side. And at the same time, I'm going to zero out the x-axis. Now I want to turn the cross slide to where I just touch off. Got my RPMs down. And in this case, you pretty much got to kind of listen for it. All right, that's touching. So I'll set the compound dial to 0 as well. Remembering I'm going to be pulling it toward me, so any backlash that's in this, I want to take out. I want to get my handle started in the correct direction. And just like on the external threading, we need to know how much on this dial we need to pull that in to cut our correct thread depth. I've made this little cheat sheet for you right here. Hopefully you can see that. Remember, 750 was the constant that I use. And I showed you in that previous video of why I use 750. But 750 divided by the threads per inch that we're going to be using in this practice, 18, gives us a compound travel of 42. Now, we're going to be going in reverse. The compound reads up to 100. Or, yeah, 100 thousandths. So 100 thousandths minus the compound travel 42 means we need to turn this towards us till the dial reads 58. That will have moved this 42 on the compound travel. All right, enough talking. Let's do a little thread. One more thing I got to tell you. I cut this internal relief in here, thread relief, so that it's right at this point on the threading bar here. So that's where I'll disengage the half nuts. We can use any number on the half nuts as long as it is one of the numbers. And this is going to be the same routine as external threading. All right, I pulled my compound back 5 thousandths now. I'll wait for a number on the dial. And I can actually hear that when it stops cutting, when it gets in that relief area. Let's see. I forgot this step. Alright, I'm at the end of my thread cut. I'll move the compound in. I can't go a whole lot because I don't have a lot of room in here, but back it off enough to clear the threads. Come back out with my carriage. Bring the compound back to 0. Draw the threading tool towards me just a little bit. In this case, I'm doing 5 thousandths at the time. Engage on a number. And I'm going to kind of speed through this routine until we get a little bit closer down. Occasionally, you'll see me do a spring pass where I will not advance the compound. Also, with internal threading, it's important to keep your chips cleaned out, especially when you're threading into a blind hole as we are here. We'll make a spring pass this time. All right, we're down to our 58 reading on our compound. So we'll make this pass a spring pass, and then we'll do a test fit. All right, let's see if we're fitting. Starting to get a little snug, about halfway in. We'll take a couple more thousandths just as soon as I answer this phone. Okay, sorry about that. See where we left off. All right, I've got the compound back at cross slide back at 0 here. Wanted to advance just a couple thousandths. This will put it down to instead of 58, about 55. We'll cut that and try it again. It didn't like much. It was just probably just a little burr in there. Yeah, you see it took just a little bit out there. Now let's try our workpiece. I believe it's going to go all the way. Up to the shoulder. All right, let's turn back to the workbench right quick and do a recap. Plus, I want to show you what was going on the inside here. All right, as I said earlier, off camera, before I started this video, I did the other end of our workpiece. And I normally try to do a practice run on videos that are how-to videos, if you will, such as this series is. For regular project videos, I don't always have the material to make a practice run first. But in this one, as I said, I bored it out to the 578, which was the bore size or drill size for a 5/8 18. I then used an internal grooving tool and cut a thread relief. I think you can see that in the video. Let me get my dirty fingernail out of there. Relief here. And then threaded it internally, just as you saw we did this end. And this cutaway here shows you the threads, 18 threads per inch, and the relief. This is the end we just did on camera. So let's right quickly talk about the difference between internal and external threading. One thing I want to point out, wearing long sleeves working on a lathe or working on any tool where you've got a rotating shaft. I don't normally do that. It was just extra cold here in the tin barn this morning, and I didn't stop and think, and I was working the lathe with a long sleeve, in this case hoodie on. Now, one thing I will say to my own defense, I've done this before, and after the fact scared me so much, I pulled the strings out. I do not have any strings in any of my hoodies that I wear out here in the tin barn. So again, don't operate machinery with long sleeves on. Wait until it warms up, get your heaters going, warms up. Okay, let's talk a little bit about the difference between internal and external threading. In this case, on an import lathe. Three major differences really. First is your compound angle. This is the angle that you would normally set your compound at for external threading. As you can see, the compound is pulled over, we'll say to the right, so that we're feeding northwest. In an internal situation, we have our compound set in the other direction, the other side of 0, 29.5 degrees, and we're feeding in a southwest direction. West being toward the chuck. We're always, in the scenarios I've shown you, we're feeding toward the chuck. Now there are other ways of doing internal and external threading in regards to feeding. You can feed from the thread out. That's perfectly fine. But what I think I've shown you in these last couple of videos is the most accepted way, or the most common way of threading. You can also do plunge threading. You don't have to pull that or push your cutting tool at an angle. You can go directly in if your lathe is stout enough to make a full V cut instead of just cutting 1/2 of the V. The other thing is the tools. You'll note that one tool is set up to go on the left side of your quick change tool post, perpendicular to the workpiece, and plunge or go in towards the work material to cut the external threads. What we just cut was internal, and you note that it is a smaller tool that goes inside the workpiece and is drawn toward the work, toward the inside of the work. Third thing you have to watch out for between the internal and external threading is the clearance, and we talked about that just a little bit. When you're doing internal threading, especially on something thin piece of material up in the chuck, you've definitely got to watch for clearance. You're taking a big chance feeding like I was, and again, you can feed away from the chuck if you want to, but just keep clearance in mind. Hope you've enjoyed this video, and I want to give you a little hint on next week's video. And I know it'll work, so it shouldn't change. But I've got this piece of, it's chrome plated, it's not stainless steel, it's a piece of chrome plated welded pipe, welded tube, and you can actually see the weld joint in that tube. I want to thread that internally. And then I want to thread a cap to go on it. Let's get the other end that's already done. You say, well, Lee, what's the big deal about that? And guys, it may not be a big deal, but it has been to me ever since I got this lathe, and I may be overthinking it. But you can go to the Machinery's Handbook, or you can go to one of these charts like I showed you this Starrett chart on the wall back here. If you've got a nominal size male thread or nominal size female thread, you can go to Machinery's Handbook, or you can go to that chart, and it'll tell you what the other piece should be. Such as if you've got an internal 5/8 11, it'll tell you that you need to go to a, what did I say? 5/8 11? You need a, or 5/8 11th male. You need a 17/32 hole to start with to do your internal threading. But what if one of these, the chicken or the egg, whichever came first, is a non-nominal value. Let me find my calipers right quick. What I did was put this piece in the lathe with the weld joint in it and bored it just enough to clean up that weld joint. No idea what size that came out to be until I measured it. And that measured 1.180. You're not going to find 1.180 in the machinery's handbook or on the chart to tell you what size studs you need to cut 18 threads per inch to fit that. So next week's video is going to be internal threading, and then we're going to measure whatever it comes out to be, and we're going to cut external threads to make a cap to go on that non-nominal value. And I'll show you a little trick that I learned from Joe Pyzinski that I think you'll, if you watch his videos, you may recall it. It was one of his, I think he calls them shop gems. So come back next week and watch how we match a non-nominal thread, internal and external. Take care, and I'll see you on that video.